Howdy doody, everybody. It's Mrs. McPhail. Your objective for today, or learning target, is to be able to use time equivalents to solve math problems. You should also be able to, by the end of this video, to write and read numbers up to the millions place. So some vocabulary to go through first. We've been learning about numbers and, of course, digits. Digits meaning a number, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And sometimes it is just remarkable, all of the numbers that you can make in the world that come from these numbers or these digits right here. It is phenomenal. We'll talk more about some large numbers today. Place value, the value of the digit in a number. For example, in the number 37, we would say the value of the 3 in the number 37 would be 30 because you have 3 tens. And time equivalent. The definition of that, or how you could describe it, would be that would be like times that are equal to each other, but they have different units. For example, we know that 1 day is equal to 24 hours. It's the same amount of time, but they have different units on them. So we're going to do a little bit of work with that today. I want to remind you that you can use your calculator if you need to during this activity because you will be working with some pretty large numbers and you'll have to transfer numbers from one unit to another. And it's okay to use a calculator. You can also do multiplication by hand, which I'll show you both ways. Both are good habits to be able to do. So let's take a look at our first question here. We know that there are 365 days in 1 year. So these are kind of like word problems. So let's reinforce what we know about word problems too, is that when we know information, we like to circle it. So we know that there's 365 days in 1 year. How many days are there in 2 years? So we know that we have to find how many days that there are in 2 years. So we're going to underline that question, okay? So 365 days in 1 year times 2 years would be equal to, and I should have written days down here. So if you were to solve this, you could do this a couple of ways, right? You could do 365 2 times, so you can add it together. 5 plus 5 would be 0, or 10, I'm sorry. 5 plus 5 would be 10. Bring the tens place over. 6 plus 6 is 12, plus 1 would be 13, so you drop the 3 and bring the tens place over. 3 plus 3 is 6, plus 7 would be 730. So 730 days in 2 years. Now ask yourself, does that make sense? If you have 365 days in 1 year, does that make sense that you're going to double that amount in 2 years? So you can ask yourself too if that question makes sense to you, okay? You also could have done multiplication, 365 times 2. You also could have, that is not the right one, used your calculator and punched in 365 times 2 and gotten 730. Here's the cool thing with time equivalents. You can go between just one step. For example, let's say Mr. Nutty is 8 years old, and I want to know not only how many days old he is, but how many hours old he is, and oh my gosh, how many minutes old he is. So how are we going to do all that? Well, one step at a time here. Let's start with what we know. I'm going to switch my pen color just to make it a little easier for you to see here. Let's do yellow. Let's start with circling what we know. We know that Mr. Nutty is 8 years old. Oh yeah, look how beautiful that is, bright yellow. We want to find out how many days old Mr. Nutty is. Well, we know from our time equivalents that 365 days, we're not going to talk about leap years here, we're just going to say roughly about how long. It's like an estimate. We know that 365 days is equal to 1 year. So really my question should be asking about how many days old is Mr. Nutty because we're not accounting for leap years. So if I know that there's 365 days in 1 year and I'm looking for 8 years, what do you think I'm going to do? If you said multiply 365 days times 8 years, you would be correct. So let's take a look at our answer. You can either add 365 together 8 times. You could do 365 times 8, or you can do that and then check your work on the calculator. And just for the sake of time here, I'm just going to do it on my calculator. So 365 days times 8 years would be, oh, Mr. Nutty, you're 2,920 days old. So I'm going to write 2,920 days old, okay? All right, we're going to get into some big numbers here. We now want to know how many hours old Mr. Nutty is. We also know now that he's 2,920 days old. So we also know on the side over here that 1 day is equal to 24 hours. So we have both of our information here. Remember, time equivalence, it's the same amount, just different units. Okay, so we know that Mr. Nutty is 2,920 days old, and in each of those 2,920 days, we had 24 hours. So we would have to multiply 2,920 days times 24 hours. Now, this would be a lot to add up. If you know multiplication, you could do 2,920 times 24. You could also just get out your calculator and find the answer, because this would be kind of hard for you to do by hand, but certainly go ahead and try it. I'm going to move mine down here. All right, oh look, I still have my number in here too. That's awesome. So 2,920 days times 24 hours means that Mr. Nutty is, oh my goodness, 70,080 hours old. Notice I didn't say anything with the 0 in the hundreds place here. 70,000, imagine there's a little comma there. The calculator doesn't put it in, at least this one doesn't. 70,080 hours old. So 70,080 hours old. Okay, we're not done yet though. We got to find out how many minutes old Mr. Nutty is. About how many, okay? So we know that in 1 minute, or I should say 1 hour, because now we're going to minutes from hour, we have 60 minutes. Okay? In those 70,080 hours, each of those 70,080 hours has had 60 minutes. So, here we go, 70,080 hours times 60 minutes to find out how many minutes old Mr. Nutty is. Now, if you think this is going to be a really big number, I would have to agree with you, because we're multiplying 70,080 60 times. So here we go. My number's still in there. Times 60. Whew! Look at that number. Mr. Nutty, congratulations. You are ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, 4,204,800 minutes old. About that. So I don't even know if I can remember that. I'll try to write it down. And I forgot my comma. I'll go back and add it in. So you can see that you can use time equivalents to find kind of like shorter increments of time, but also kind of expanded increments of time too, if that makes sense. We just went all the way from finding Mr. Nutty's age in years to about how many minutes old he is. So it's kind of cool what you can do with time equivalents, and it's also cool that you're able to work with these really huge numbers as well.